Okay, let's get started. Looks like I've collected all the project area selection documents here. That's great. You're going to use that on homework number 11. I gave you homework 11 in class last time, right? Okay, good. So with that assignment, what you're going to do is perform an analysis on the watershed you're interested in, or if you have some trouble and your watershed turned out not to be as interesting to you as you thought initially, or if there's some other problem, I provide you with a list of a couple of other possibilities in that homework handout. So I'll collect that when we get back together on Tuesday, the 18th of November. Now, as I mentioned last time in class, next week we're not going to be meeting together. And so on class 23 and 24, there is a recorded demo that I'd like you to work through to reinforce what we're going to do in class today. Repetition is really the only way to get proficient with a multi-step software package like you have to follow for watershed delineation and modeling and WMS. So you need practice. We're going to get through, I hope, from beginning to end, one watershed today. And I don't know if that's a realistic hope, because it seems inevitable that, you know, like with this many people, that someone's computer will crash, or that, you know, there's some slight differences in the versions that are installed on the tablets versus what we are going to be using if you just downloaded and installed it recently. So hopefully we'll make it through. So next week's class, what you need to do for that is watch the link that's provided, and I'll show you, you know, in MU Online, which is where I put all of our recording links. Go here to class lecture recordings. So this is our class page, MU Online, and you'll notice two of them. At the bottom here, it says class 23 and 24. This is the main one. It's 23 minutes long. This is the one that you're supposed to mimic. And later on, after recording this, I also went into more detail about stochastic modeling. In case I don't show enough details or I went through it too quickly in the demo here. And by the way, if I'm going fast in the demo, you can always pause it and find the buttons that I've clicked, let your computer do the execution, and then unpause as you move forward. But anyways, this 13-minute video that's the last link under here, that's just a supplementary thing that shows a little bit more details about stochastic modeling. And what stochastic modeling is a way of executing a batch of simulations. And so you set up your watershed model, and instead of telling it to find the runoff amount for a certain storm, you set it up and then you say, here are 100 storms I want you to run the model on. And then bang, 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 bang. It'll just go through the model as many times as you want, and it'll find the runoff for different precipitation amounts, different curve numbers. And it's a way of handling uncertainty. If you're not exactly sure what the design storm is, or if you're not exactly sure for some of the soil values or land cover, and you have like a spread of curve numbers that you think it's between this and this, well, you just run every possible combination in between, and you find out how things look among that batch of models. And so this 13-minute video just demonstrates that process, that stochastic batch modeling process again. So what I'd like you to do is watch them both, but the thing that you have to mimic is this first one. It's the 23-minute video, and what I ask you to upload, if you go to the main class page here, there's some place where you're supposed to upload an Excel file. And the Excel file is actually the runoff hydrograph data you can export to Excel, and then where it says stochastic modeling activity, that's where you it comes up as an assignment, and that's where you can attach the file. So I've just handed you the handout for next week's two classes, and I mean, it's all the same information I've just given you, except that I gave you the project area that you should work in. It's also on screen, but as I was looking at it, the numbers seemed awfully small, so I wanted to make sure that you were able to see what the project area is. Okay. So any questions about what you should do next week? You can still come here to the classroom at 9:30. But I won't be here. And probably a few of your classmates will too. But you could watch the demo and, you know, keep a vigil, light a candle, think about hydrology. But we'll meet together again on Tuesday, the 18th of November. All right? Hmm? Yeah, right. Okay, so with that said, let's dig into WMS. The project area we're going to work through today, I gave you handouts. Does everybody have a copy of this Activity 1 and Activity 2? This is a flowchart outline. Yeah, so register. And if your computer's not registered, it's PUTMXX1, right? We're all going to have that memorized. Okay. This doesn't tell you exactly where to click and what tool to use, but it's kind of like a flowchart, a procedural summary of what we're going to be doing. So last time I told you that there is this hydrologic modeling wizard. It looks like a wizard hat on roller skates for some reason. I don't know, because you skate through the modeling process maybe. Click on that, and the first thing we're going to do is save your project. So browse to a location, whether it's, if you're using the tablet computers, you could go to your V drive, or you can insert a jump drive and browse there, but go someplace that you know how to find. Don't bury it in some desktop folder that you'll never find again, but create maybe a temporary folder. WMS Day 2 is what I'm going to call it. And then Darnell Road. Now I'll mention that I uploaded to our class website this file here that says WMS demo Darnell zip file. If you fall behind during today's lecture and you basically get lost and we leave you behind, it's like on when the pioneers were going across the plains, you know, like if you fall behind and the wolves attack you and you don't finish the demo, you can come back and use this, unload this zip file and see basically what the finished product looks like. So in other words, this is the answer to today's demo. Now you're not submitting anything for today's demo, so it's not like I'm short-circuiting your learning process, but if you want to look like what it was supposed to, what you're supposed to have at the end, it's online. Okay, so you've saved a file. Remember, you have to click the Save button. It's not just browsing to the location and saying Save. You actually have to write what the name is and then click Save. And the way you know if it's saved or not is up here at the top. If it says untitled.wms, it hasn't saved anything yet, but once I click that, now it's a saved project file. Okay, click Next to get to the next screen here. And the thing to check on is the project projection. Raise your hand if anybody has something other than UTM NAD 83 meters. All right, so lots of people. So what does yours say? Does it say geographic? Not defined. Okay, so click Define and Global Projection. We're going to set projection, set it to UTM, Zone 17, NAD 83 meters. For today, you'll do Zone 17, but you'll need to Google UTM zones, and you'll find the first thing that'll come up is a map, and it shows what states are in which UTM zones. And so that's a good question. I'm glad you asked it. Your project's in Texas. That's definitely not Zone 17. So you'll just need to find out what zone it is. Otherwise, the data won't line up. You know, like things will be in the wrong place. Okay, so did everybody define their projection to UTM NAD 83 Zone 17? Now then, the vertical, you need to have NAVD 88 and meters. So both side to side and up and down, there's a datum, a standardized starting place that this coordinate system assumes you know. And so you have to tell the computer where the coordinate system is based on. Eric, have you got a question? It is from The second one, so did you do saving this?
No. Yes.
Okay, so the wizard hat with roller skates brings up this. You save the name, and then next is project projection, so define here. Do you have it? Okay, good. Okay, so then project boundary, and my view might be zoomed in already on West Virginia. Yours might be the entire map of the United States. But what you have to do is have a basic idea of where your project area is. And that's why I gave you this map. We're going to zoom in on Huntington, and maybe if you're not from Huntington, you couldn't find it on a map. That always makes me nervous. If I can't find where I am on a map, I feel very anxious. I'm traveling next week, and I've already looked at the maps to know exactly where I'll be. Not that I could walk home, but anyways. So here's Kentucky, West Virginia, Ohio. We're right at the junction of those three. So start zooming in on the tri-state area. And now finally, we're zoomed in enough we see Huntington and Charleston. We're going to zoom in closer to Huntington. All right, so we're getting closer now. If you look at the map that's on the paper I gave you, we need to zoom in. Sometimes you have to be a bit of a detective. We're going to be zooming in on, you see West Pea Ridge Road is there, and here it's saying East Pea Ridge. If we zoom in a little bit more, we have to sometimes just go by trying to find certain roads. There's Cabell Crest. I see it both on the screen, Cabell Crest, and I see it on the paper. That's 44. And here's Spring Road. That's another clue that we're in the right spot. Still, we need to zoom in more. Now, we could make this our project area. It's always better to have too much data than not enough. If we know that our watershed is somewhere in the screen and we say OK, then it's fine, except for it takes so long to download the file, and when you save it, it takes up extra space on your hard drive. So, and then every tool you use, every time it executes, like for example Topaz that I told you about last time, is how it finds which cell the water will flow to. Everything takes longer if you don't have the right project area. So I'm going to take a pause right now and see how it's going. I think maybe some of you are having technical issues. You're zoomed in, looks good, yep. Are you having trouble?
Yes.
Click here again, and now again. There it is. Yep. Okay, so project file name, did you do the top? Okay, click save. Okay, you already have it, good. Sometimes it goes away, and so, okay, then next for this next one. Yeah, looks like you got it, yeah. Zone 17. Now, instead of local, do NAVG 88. Yep, okay. And now define. Yeah, sometimes, let me show you. If you click down here and then bring it up, okay, so do this. You already got that. Make this NAV and then meters, okay, and then define. Okay, and it'll take a minute for it to load the image, but there you are. So zoom in on West Virginia. There's Barboursville. Yep. Okay. Morgantown, Parkersburg, Huntington. So zoom in over here. All right. 1, not I. Yeah. Ooh, what's this? I clicked maybe the wrong thing. License code. Okay, now it's fixed. So the wizard with roller skates. Here you say, saving the project, we'll just save it on the desktop and start a folder. Okay, model, save, save. And then now here you can define the project projection. UTM, this one, global, yeah. All right. Good, good, good. All right, we're getting there. Can you double check if she gets the right zone and everything? Okay, so try to, as much as you can, zoom in on just the area that's shown on the screen there. And by the way, you can see right now I've got this this tool over here. If that's getting in the way, you can switch it off. There's also a way, this locator tool, sometimes it works. If you have no idea where a town is, you know, like if I wanted to say Plano, Texas, then it'll go find Plano, Texas for you. Or, I don't know if it works all over the world. Like, yeah, it does. All right. So back to, no, we're not going to play with this all day. All right, Barboursville, West Virginia. All right, I'm going to turn that off. All right, so I think that the extents are right here. If I zoom in too much, let me tell you what the risk is. Let's say that I'm only going to download, if I zoom in too much, I'm only going to download what's on the screen here. But if my watershed actually continues off the screen, then I have to start the whole data downloading and delineation process over again. And that's not the end of the world. I've done that plenty of times. It'll be very obvious, like you'll, instead of an irregular shaped watershed, you know, typically a watershed will look like this. It's just, you know, where this line is a bunch of hills and ridge lines. But if you don't download enough data, like if you didn't go high enough, all of a sudden your watershed will have this nice straight line. And it's not that there's a perfectly straight mountaintop there. It's that your limits of data that you downloaded didn't include the whole watershed. So I don't want to make that mistake. I'm going to zoom out and make sure that I've got everything that's shown on the screen here. Okay, so once you say OK, remember there's that issue where our wizard goes away? The way to get around that is just click on the icon and then again, and it'll bring it back up again. So I don't know if all of you experienced that or some of you or just me. But so now we've got these coordinates. You can, if you've got the coordinates like you will for the activity you're doing next week, you can just type it in. Okay, click Next. And what we're going to do is use the web services to download the data. So make sure that that's clicked. Use web services. Click down here. And again, there it is. Okay, project define. Just 1 second. It's this. It sometimes goes away. So now you zoom in. No. Okay, that's maybe too much. Perfect. Click down here, and there it is. All right, so define. Yeah, that's good. So click OK, and move that up. Yep. Didn't take it, huh? There it is. Go back. Stick it close. Go back, and then next. Back, and then next. Okay? Seems like some of you are having a bug I haven't seen before, and that is even after you define the project bounds, it's staying blank. So if you go back and then next, after you've browsed with the map where it should be, then I think it will come up with the coordinates again. Always an adventure, right? Yeah. By the way, this software package is basically programmed by students. So it's amazing that it works at all, much less as good as it does. But well, I don't know. When I was an undergraduate student, I sure couldn't program like this. So I think every time I use it and it actually gives me a good result, I'm astonished because it's literally like undergraduate and some graduate students that are doing the core development of the program. All right, so here's the list of the data that we're going to download. We want to get, for this one, the 10-meter resolution DEM, NLCD, and Surgo soil. Now, I think if you're using 9.0, maybe it doesn't give you the Surgo soil option. Is that right?
Yes.
Web services. You have to click the web services button. Wait, maybe it was just loading slowly. There it is.
Oh,
all right. Surgo and NLCD, yeah, and NED. So move this over so we can see more. Yeah. Okay. Yep. That's good. Now scroll down a little bit more. Yeah. You can't get the NLCD since it's the old version. That's all right. That's just a small part of it. So I think the 9.0 version, they didn't have NLCD available. But you still can get the Surgo. You can still get the DEM. Maybe if we have time at the end of class, we'll install the new version of WMS on these computers. Okay, so once you have those three things selected, or two of the three if you're using the old version, then click Download Data from Web. And we're about to crash their servers by all downloading at the same time. So let's do a denial of service attack in 3, 2, 1, go. All right. So when you get prompted, enter the 10-meter DEM cell size. 30 meters, I think, is referring to the NLCD. Last, it gets the shapefile data. It doesn't prompt you to resample the shapefile data because shapefiles already are they're vectors rather than rasters. Did it crash? Good thing you saved your work. Yeah, close the program. Yeah, retry if it will let you. Yeah. 10. Yep. That's right. Oh no, you have it. No, it. Okay, so the DEM, NLCD, and Surgo. It's all three. This must be a newer version or something. Okay, so 10. No, 10 for that one. All right, your download went okay. You've got the DEM. That's what you're seeing there. So it's okay. Cancel that. Close that. Downloading. All right. You know that things worked okay if you are seeing. You can close this window at this point if you see I'm going to close the shapefiles. This is a good thing to see. It means that you have the elevation data. Uh-huh. It's thinking hard. Oh, look, it was doing stuff at the bottom there. Look at this. It's making progress, right? Reading the file. Down at the, if you're worried it's just locked up and doing nothing, look down here. There's some red text that maybe it'll say as it's reading in the data, because these are pretty big data files. That's okay. The black and white is the soil data, and you can turn that off if you don't want to look at it. Like if I zoom to extents, if it looks like this, that's fine too. Just you can turn off the soil data for now, and we'll come back to the soil data later and zoom in on the elevation. Good, you got the land cover data there, the DEM. It's still working? Yeah. That's okay, as long as it's still working. Yep, it's reading in the soil data. It takes a long time because I don't know why it's so clumsy at downloading soil data files. You can see that it downloaded 3 different soil data files here. I'm only going to need one of those 3. I think the one I need is West Virginia 11. But I guess it's probably my mistake because I think that this isn't the Ohio River here. I think this is, up at the top of the map we had the freeway. So it's just clumsy at identifying the right one. Like if you zoom out, turn on all of the soil data and zoom out, you can pick up which one you want to get rid of. So I don't need this one at all because my elevation data isn't behind it. So I'm going to speed up my computer. It really gets bogged down when you have all of these soil shapefiles attached. So since I've verified I don't need West Virginia 99, I'm going to right-click on it and delete. And by the way, this is a good time to save. Once it finishes downloading everything, click Save again, just so that you can come back to your work when your computer crashes. Is it responding now? Yeah, it's a bad combo. These tablet computers have a 1.8-inch hard drive that spins really slow. They've got a weak processor, and we're working with gigantic data sets, so it's just really a match made in heaven, these tablet computers. That's a 6-year-old computer, 8-year-old computer? All right, so delete the soil maps that don't apply. You saw how I deleted one. Let me pick this other one, the Ohio one, verify that it's useless to me. If I don't see the elevation data peeking out, I don't need it. So I'm going to right-click on it, delete, and then I'm going to save again, just so it knows that if I crash, I'll come back with these shapefiles already gone. Now, let's take a look at the file structure, where I saved this project, like what is on the computer right now because of what I just did. WMS Day 2 is the folder I'm working in. Here is the data that it downloaded from the website, and you can see that it got 3 different Surgo soil files, and that corresponds to the 3 shape files that were there. And as zipped files, they're between 15 and 60 megabytes, and when they unzip, they're considerably more than that. The one that was the biggest is this shapefile 3. Right-click and see how much there is in that folder. It's 110 megs when it's unzipped, and so you really want to unattach those if you're not going to need it. So here is the soil data that it downloaded. You can see the WMS file, which is like my project file. STO, I think that is related to the structure of the model. I'm not really sure. It's pretty small, but now here's the NLCD. It says it's a TIFF, and if any of you know much about like images and photography, a TIFF is an image file, and we can open this, the NLCD. This is the land cover file. We could open it with just an image viewer. Like if I open it with Paint, it'll just look like a picture. So each color represents a different land cover. And red, I mean, we know a little bit about what should be on this map. Red is urban areas, because remember at the top of our map was subdivisions and the freeway. Green represents forested areas, and yellow is probably some different kind of forested area. I have a table that I'm going to use that translates this this map into actual land cover types. Okay, so that's a TIFF. And the other thing is the elevation data is also a TIFF. So I could open that if I want with a file here, but nothing's visible. It's basically an XYZ file. So this NED10, that's National Elevation Data Set, 10 meter resolution, is what gave me this, the elevation data. All right, so here on activity 1, we have gotten all of the data, and once you get rid of the soil maps that you don't need, save your work again, and then we're going to run Topaz. So go to the drainage module, so this one that looks like a watershed, and then the DEM tab, compute flow direction / accumulation. Now, what happens if you forget that that's the next thing you're supposed to do? Well, you can turn the wizard back on and find where you were last. I was at watershed data. I got my download data. I don't need to read the data because I was using web service instead of catalog. Then it reminds you that the next thing to do is compute Topaz. And so I can click the button right here too. Compute Topaz, and it does its thinking, normal program termination. Probably won't be that quick on the tablets. It'll probably take 2 or 3 seconds to execute. Once you close that, that's when it starts to give you what looks like the streams, the little blue lines in here. So has everybody executed Topaz? If what? Okay. If you turn that off. Oh, did you tell it to do Topaz already? Okay. So close that, and you can turn off the soil layers. And zoom in with that button right there.
Express its unique and other stuff.
Oh, really? I don't know. Let's see. It kind of doesn't matter because it's like the threshold you choose isn't committing you to anything. It's just a display issue. And so you can change the threshold anytime you want and it'll show more or fewer streams, but it's not like an irreversible decision. So let's see, in my display options, my threshold here, it looks like it's 12.8 acres. I'm going to change that to 15 acres. Okay. And it brought the streams down a little bit. All right. I'm going to add a map now because I'm not exactly sure just by looking at this DEM data where the crossing is that I'm interested in. You know, it might be that there's a road crossing the stream, but just by looking at the elevation data, I'm not certain where that is. If I had the coordinates, like if you have your phone, it can give you latitude and longitude. Look down here. You can see it's giving you the latitude and longitude, so you can zoom in on whatever point you're interested in. But I'm going to turn on the online map, so add GIS data. or you can do the get data tool. Either one. I'll do this add GIS data, get online maps, and I'm going to do the world street map and click OK. And unfortunately, that's going to take a long time. The world street map, it just kind of streams slowly. It loads very slowly from a server. Okay, so you go to the display options, DEM data, and instead change units from miles to acres. Okay, and then change it to 15 acres. Did it run Topaz? Did you run Topaz? Okay. I just don't see, I only see a little bit of stream. So I think the default, for those of you who just installed the program, I think the default display option is 640 acres for the DEM data. Change it to like 15. So let me show you how to change it. And by the way, if you didn't already delete the extra soil data, definitely do that. The only soil data that you should still have is West Virginia 11. To delete it, you right-click on the one that you don't want and select delete. Okay, so to change the accumulation for streams, go to display options, DEM data, and then if it says square miles, since we're working with a small watershed, have it change the units from miles to acres and click OK, and then change it to 15 acres. Yeah. Go to display. You already did the Topaz, right?
No, I didn't.
Okay. So go to this Watershed module, next one, yep, and DEM, and this one, compute flow. Okay. The world street map. Yep. Yeah. Yeah. That's good. It's perfect. The map. Okay, so click OK. Click here. Get online maps, yes. World street map. Okay. Then in that case, let me see. Maybe let's try this one instead. If it really won't give it to us, then we can use a different one. Let's try the imagery. Well, I don't know. That's very strange. I'll tell you the coordinates to use. Instead of using the map, I'll just tell you coordinates to type in when we place the watershed. Yeah, I think it's because it's the old version. If you're using the old version of the computer and it doesn't download, and it doesn't download the maps, I'll tell you the coordinates to type in when we place the outlet. All right. Do you see the picture that's here at the bottom? We're going to try and find where the watershed crosses the freeway. So I'm going to zoom in on that location over here. If I remember correctly, it's around here somewhere. Yeah, I think it's this one. So whenever you zoom in, it kind of updates the map. No, actually, on second thought, that's not the one. It's not looking like it. Well, let's see. What do the roads look like? Yeah, okay, yeah, that is. That's right. Darnell Road. Yeah, there it is. See Darnell Road? Okay. So go to the drainage module, and then this yellow button, create the outlet. And if you don't have the picture, it makes it hard. But what you should do is, let's see, how would I do this if I didn't have the picture? It's like that scene on Star Wars when he's got the thing over his eyes, you know? Let's zoom. Okay, so zoom in on this zone. Ooh, which one was it? That's hard. Darnell. Ah, okay. It's here. All right. So the one that we want is when those two streams come together. So the outlet point you need to drop once the two streams come together, right there on I-64 West. The coordinates, you can see, you should put it at .381, 848. Now you won't be able to move your cursor to exactly that spot, but 381, 848, and then 381, 848, and then 4,252, 130. So it's just that yellow outlet that you want to put. And if you put it in the wrong spot, let's see, I think you can select it. Let's get this. There's some way to change its location. Okay, does everybody have an outlet placed? It doesn't matter if it's exactly in the right spot, but it should be, if this is the whole area, here's the river, the main one. It won't load the map? Yeah, that's fine. You don't need it. Did you already change the accumulation like so that it's 15 acres? Okay. So it looks like you put it over here, right? Okay, we actually want it, it's pretty close. Yeah, we actually want it over here. Yeah. So just put another one there. Okay. Mm-hmm.
This program for a Mac.
It'll run on a Mac if you have Windows installed on a Mac.
All right, got it.
If you have like Basecamp or Basecamp, I think it's called. So it is this one. So put the outlet right over there. You've got the outlet placed. It should go here. Mm-hmm. Let's see. I'll move the cursor away. Good. Good. Yeah, that's perfect. All right, good. If you select it like this, and then press the delete button.
Oh.
Yep. Yep. How's it going here? Low on power? You can move to a different seat and plug in because the outlets are over there. Okay. What do you want me to do?
No, I have to watch again.
Okay.
It doesn't work like when I try to download.
Mm-hmm. Let's see. Do you have a project? Well, it did download the data. You already have it. Yeah, that's good. No, that's what you want. That's good. Yeah, it's fine. Okay, got the outlet. Okay, when you've got the outlet placed, the funnest part of the whole process is when you click the next button. This is the funnest part of the process. When you go, you can turn the wizard back on and choose an outlet location. We already did that. Click on the Delineate Watershed tab and then push the Delineate Watershed button. And now that's where it's tracing all of the ridge lines, and it found the watershed area. So those are all of the little mini watersheds. You know, when we were tracing them using Google Earth, really it was only possible to do the small ones just by looking at it. But this is going in all of the streams, it's going upstream and finding the high point for the ridgeline and tracing it to find the overall watershed. It's just what you have selected in the display options. For me, it's showing curve number, base and slope, perimeter. So here in the display options, I think it is, drainage data. I'll turn off perimeter. Maybe I don't care about perimeter. I can turn that off and it doesn't show it anymore. It's the different areas based on where you put the outlet. So if you accidentally only got one of these streams, then the basin area will be radically different. If you were a little bit further downstream, then the basin area would be slightly different. But the basin area depends on where you click. Okay? Then it created two watersheds, right? Yeah. All right. So to delete the one that you don't want, it's actually best to delete them all. So we'll do this tool, delete this, delete that. At this point, actually, it might be impossible to fix. Sometimes it works, sometimes it doesn't, to fixing it. It's a tricky thing. Delete. Okay, so now there are none. Okay, and you can put it here. And then delineate watershed. And it'll say, do you want to delete all the old ones? Hopefully, there will only be one.
What if mine's like big one?
Then that means that the data was cut off. Well, no, actually, I think it's just only part of the watershed. You clicked before the two streams went together. So the actual outlet is after those two join. So it is, it's here that you want it to be. And then the other one we should delete. And then redo the watershed model. Yeah, excuse me. It's pretty important to get the outlet in the right spot. And if you put it in the wrong spot, it's like almost impossible to ever get it right. So that's why I save my work really often is sometimes if I put the outlet in the wrong spot, then I'll just close the file, open it again, close without saving, open it again, and start over. So let me do that. Let's say that I put the outlet in the wrong spot. I'm going to close this, not save it, and open up my Darnell Road project again. I don't remember when the last time I saved. No, not Windows Media Player. Open with WMS. Okay, so let's say I had the outlet in the wrong spot. What I'm going to do is I'm going to run Topaz again. And then I'm going to zoom in the right spot. You always want it after the two streams come together. So here is one stream, here's another one, and I'm going to click it I'm not going to try and get it as soon as they come together because that might confuse it a little bit. I'm going to do this cell where it's definitely the two streams came together, DEM, delineate basin, close, and there it is. There's the right one again. So don't be afraid to just throw away your work. If you've got it in the wrong spot or if you have several different outlets placed, then sometimes you'll get these tiny little watersheds that have like 0 area. But if I put in another one, I can break this overall watershed up into pieces. Like if I dropped another outlet here and there, and then I delineate again, then it'll have different segments. It'll have one that is 400 acres, this one's 270, that one's 385. So however many watersheds how many outlets you place is how many subbasins it'll break it up to. But like I said, if you try to delete one, it'll never quite be the same. Even if I delete those outlets and I tell it to delineate again, oh well, maybe it is the same. It looks pretty good now. I've had problems in the past, like when you delete the unwanted outlets, then it still saves some of the model structure, even though those outlets are gone. Sometimes the basin boundaries are still shown in the background. But Maybe they've fixed that with the newer version of WMS. Okay, so the watershed is delineated, and on the form here, I'd like you to just write down the watershed area, maximum flow distance, and basin slope. So to maximum flow distance, to get that, you have to go to display options and choose the one that says drainage data, and then turn on max flow distance, basin slope, and basin area. And with those turned on, it'll do the calculations to find out. Basin slope, sometimes if you haven't done a lot of this, you can't appreciate how extreme the watersheds in West Virginia really are. This means basically 23% average slope. And 23% is really steep. Like they have to put warning signs up on roads when you get to like 4 or 5% grade because it's so steep. And here we are talking about a 23% slope. So this is an extremely hilly watershed, and that means it's going to have very quick times of concentration. It's kind of redundant on here, isn't it? Maximum flow distance is on there twice. All right, one way to reduce the size of your data set is to trim out the areas that you don't need anymore. So we don't need all this extra elevation data here. So you can right-click on the terrain data where it says that this is the DEM file here. I can turn it off, turn it on. I'm going to right-click and trim with a polygon and enter a polygon interactively, and then it allows me to go through and select what data I want to keep. And once I double click, then it trims all the stuff I don't need. That's not a required step, but it's just a kind of a way of cleaning up the model to get rid of unneeded data. So that's the trim DEM to include only areas within the watershed. All right, right click where it says DEM. Right click, trim. Polygon. Yep. Let me show you where to access the tool to trim again. If you have the original DEM over here under terrain data, you right click and then it says trim polygon, and then enter polygon interactively, and that's when you start tracing. Okay, so here's the next step, is that if you do have the soil data, there's an important thing that we have to do, and we have to join all these shapes to the underlying table. There's two things in this soil data file. In the shape file, there's like the shape of what it looks like, where the soil is. And then there's also a database that gives information about each one of these shapes. And the main thing that we're interested in is the hydrologic soil group. Looks like it's still reading a file in there, right? Okay, so what you have to do, it's very easy, but you have to remember to do it, which is sometimes hard. See this file? Right-click on it, join NRCS data. And then we want to join the hydrologic group. Soil texture, it doesn't matter if it's there or not. Doesn't matter. What we do care about is this hide group. Fill blank values, you can turn it on. I I don't think it'll matter for this watershed. It's just there's certain very small spots where it doesn't know what the hydrologic soil group is. And so if you say fill blank values, any place it doesn't have actual data, then it'll make some assumption about what's the soil group. And you should choose C, because that's a conservative assumption that you have a clay soil. So once you click OK, then it's going to join each one of these shapes with a database file that also has the hydrologic soil group there. All right. Browse to the place where you saved the file. All right. Right-click on there and do Open With, Browse, and zoom. Scroll down to the folder that says WMS. Hopefully it'll open it up now. Okay. All right, so did you delineate the watershed again? Good? Yeah, that's good. Okay. Right click. Join NRCS. Yeah. Yeah, that is a problem. All right. When you install it on your computer, or I'll make sure that the computers out here in the lobby have the newest version. It won't do that. Right. It's crashing when you join the NRCS data?
Yeah, it doesn't work.
Yeah. I'll make sure that the computers in the lobby have the new version of WMS, have 9.1 installed on them. If you install it on your own computer, they won't crash. Basically, we're using an old unsupported version of WMS on the tablets, and so unfortunately that's why it didn't download the National Land Cover database, and it's crashing when you join the soil data. I'm sorry that that's the case. So you've joined the data, and let me show you what the next step is. Here under coverages, we have automatically something called a drainage coverage. We need to create another one. We need to create a soil coverage. So right-click on where it says coverage and do new coverage, and change the type from general to soil type, and click OK. And what we're going to do is we're going to move this soil data that exists as a shapefile into the soil type coverage. And the way we're going to do that is we're just going to select the shape files that are in our project area that we care about. So let's switch to the GIS module across the top here. And then there's a tool that allows you to select features. Actually, I think either one of these tools will work. Right, left click and just select the soil shapes that are over your watershed area. And if I zoom out, you can see that any one that is continuous sort of spreads out and is dendritic. It goes through the whole rest of the county, but many of these aren't going to be copied over. So once you have the soil shapes selected, then you go to Mapping, Shapes to Feature Objects, and we're going to create soil type data based on this shape file. Click Next, and you scroll over, and here's hydrologic soil group, and that's good. We want to be able to see that the hydrologic soil group got mapped and that it's going to be mapped to SCS soil type. Click Next and Finish, and then it's going to move data over to that soil type coverage so that if I turn off the shapefiles, I still have what is basically my soil data, but it's now as a coverage instead of GIS data. Now I don't need this shapefile anymore, so I'm just going to right-click, delete that, and save. So again, the process is you right-clicked and you joined NRCS. Then you go to the GIS module, and you've also created the soil type coverage. You go to the GIS module, and you select the shapes that are on top of your watershed. And then you go to Mapping, Shapes to Feature Objects, and that's when you say that you're going to take the shapefile and put it into the soil type coverage. You're trying to get to GIS?
Actually, I'm just trying to see the name of this part of this.
Okay. Are you trying to select the shapes?
Mm-hmm.
Okay. The tools that are there change based on which module you have selected. And so you need to go to the, here, the GIS module. Yeah, that is strange. So selection. I wonder if we do. Toolbars. That's what you were already doing, right? Toolbars. I bet it's GIS tools. Yep. There you go. So use this one. You guys got it mapped over? This one you just do next. You can scroll over to make sure that the soil group is there, but now click Next and Finish. Okay. Create a new coverage. Right click on the word coverage. New coverage. Change the type from general to soil. Okay. All right. Now turn on this soil map and go to the GIS module by clicking on the world. Now click and drag over the entire area. Now do mapping, shapes to feature objects. Next. Scroll at the bottom to make sure that it has hydrologic soil group. Scroll over. Okay. Next. Finish. Good, you got it. Now you can delete that soil map. All right, so here's the final thing, calculating the curve number. What data do I have now? I have the DEM data, I've got the soil type data, and there's also this land use file. I haven't been looking at it, but there's the land use file that's in the back there too. If I go here to the drainage module, what I'm going to be doing is I'm going to be calculating the curve number that I'll need to have for watershed modeling. And once I've done that, it will give me the option of picking different modeling types like HEC1, TR55, HEC-HMS. Calculators, compute GIS attributes. And so what you should do is switch here into the hydrologic modeling module and do calculators, compute GIS attributes. And what we're going to use is the soil type will be the soil type coverage. The grid will be for determining the land use. And then we need to import a table that is the key to what type of land use goes along with what curve number. I think I've got it on here. I'll have to email you that table because it's one that I created based on the watersheds and land use that's in West Virginia. This curve number table. What it is it says what curve number should go along with different types of land use. So save your work. You won't actually be able to have it automatically calculate the curve number until I email that table to you. But once you click OK, then it does that analysis and you can see that it's calculated a composite curve number of 67 for the watershed area. All right, we're out of time. The 23-minute video that I've asked you to watch for next week, it has this whole process from beginning to end. I do everything. So if you missed, no matter where you got lost today, because I think at one point or another everyone's computer crashed and everybody got lost at some point, no matter where it was that your computer crashed or where you got lost, that tutorial will be able to show you this process from beginning to end. The only other thing I need to do is I'll email you that table. I'll also load it on MU Online so that you can calculate the curve numbers. So we'll meet again in person on Tuesday the 18th, but as I mentioned before, neither of our class meetings next time will be live for next week. So please be sure to plug in the tablets so that it can recharge if you've used that today. And I'll see you in class Tuesday the 18th.